লাইট দেখা যাচ্ছে?
জি স্যার।
তো লাস্ট ক্লাসে মনে হয় আমরা এখানে শেষ করছিলাম, তাই না? In the
Yes, sir.
last class, I think we have covered this topic, right?
Yes, sir.
So let us start from the next topic, that is called bipartite graph. Okay. So bipartite graph is a kind of also a graph, simple graph, that is graph equal to V comma E. What is V and what is E? Can anyone tell me? What do you understand by the V and E?
Vertex and edge.
Vertex and edge. What is vertex and what is edge?
Edge is the connecting line between those vertices or edges.
Okay. So joining points or connecting lines. So a graph basically consists of two things. One will be some nodes. These are the nodes and connection between the nodes. Basically the edge, that is called the edge. So a simple graph can be called as a bipartite if V can be partitioned into two disjoint set V1 and V2. That means what is V? V is the vertex. It is a set of how many nodes are there in the graph. That is the number of nodes. So this V can be partitioned into two set or two groups such that every edge in the graph connect the vertex V1 and vertex V2. Consider this is a set of V1 and this is the set of V2. So in the V1 set, there are these two nodes. In V2 set, there are these two nodes. And you can find from here that all the edges are connect these nodes. That means this one is connected with these two, and this one is also connected with these two. So this type of graph is known as bipartite graph, complete bipartite graph. Am I make it clear? Say it here. It is a set of V1 and it is the set of V2. And you can see the edges, they all are connected with V1 and V2. So this type of graph is called the bipartite graph. So the condition of the bipartite graph, first condition is that you need to separate the nodes into two groups and all the groups will be connected with each other. তার মানে আমার যতগুলো নোড থাকবে এই নোডগুলোকে আমি যদি দুইটা আলাদা আলাদা সেটে বলেই নিছে যে দে আর টু ডিসজয়েন্ট সেট, দুইটা আলাদা আলাদা সেটে ভাগ করবো, মানে তাদের ভিতরে কোনো কমন এলিমেন্ট থাকতে পারবে না। There will be no common element between these two set, so it will be two disjoint set. দুইটা আলাদা আলাদা সেট থাকবে V1 and V2 এবং গ্রাফের যতগুলো এজ থাকবে প্রত্যেকটা এজ এই V1 এবং V2 কে কানেক্টেড করবে। এটাকে বলা হচ্ছে কমপ্লিট বাইপার্ট্রিট গ্রাফ। Is it clear to you all? Bipartite graph সবাই বুঝতে পেরেছো?
Yes sir, clear.
Aziz and Hakim, do you understand bipartite graph? Are they in the class, Aziz and Hakim?
Yes, I joined right now.
Joined right now, so maybe you missed the part. Okay, I am repeating it. So we know graph is a consist of the nodes and the edge. Nodes are called the vertex. So vertex can be grouped or separated into two groups. This group known as V1 and this group known as V2. And the condition is that V1 and V2 are disjoint. It means that there will be no common element between these two sets. Okay. So as they are partitioned in such way that there will be no common element between these two sets, and every node will be connected with each other with some edges. This type of graph is known as the bipartite graph. Clear?
Yes, sir.
Next, we will learn about the subgraph. What is basically a subgraph? I think you know about the subset. Okay, so subgraph is also exactly the same concept of the subset. For example, a graph is G is a graph and subgraph is H. So we can call H will be subgraph in such way that W is subset of V and F will be the subset of V. So if I make it clear, for example, G is a graph which is consist of a set of node or vertex V and a set of edge E. So there will be another graph that is H which is consist of W and F. So what is W? W is also in another set which is have some member from the V. So we can say that W is the subset of V, and similarly F will be a set where there are some members of E will be in the F. So we can say F will be the subset of E. So if the W and F are both are the subset of the element of graph G, then we can call that graph as a subgraph. তার মানে সাবগ্রাফটা কি? ধরো আমরা জানি যে জি হচ্ছে একটা গ্রাফ যেখানে এর এলিমেন্ট হচ্ছে ভি এবং ই। তাহলে ভি হচ্ছে নাম্বার অফ ভার্টেক্স আর ই হচ্ছে নাম্বার অফ এজ। এখন ভি হচ্ছে একটা সেট, নোডগুলোর সেট, আর ই হচ্ছে এজের সেট। আরেকটা গ্রাফ হলো এইচ, যার এলিমেন্ট হচ্ছে ডাব্লিউ এন্ড এফ। এখন দেখা গেল ডাব্লিউ এর যে উপাদানগুলা সেগুলা এফ এর এইচ এর এর ভিতর আছে, ভি এর ভিতর আছে, সবগুলা নাই, কিছু আছে। তাহলে সেই ক্ষেত্রে আমরা বলতে পারবো যে ডাব্লিউটা হচ্ছে ভি এর সাবসেট, এবং একইভাবে এফ যে এজ গুলা আছে সেই এজ গুলা ই এর ভিতরে আছে, ই এর সবগুলা নেই, কিছু এজ এফ এর ভিতরে আছে। তার মানে আমরা বলতে পারবো এফটাও হচ্ছে ই এর সাবসেট। তাহলে কোনো সেট যদি এরকম হয় যে তার ডাব্লিউটা হচ্ছে ভি এর সাবসেট এবং এফটা হচ্ছে ই এর সাবসেট, তখন সেই সেটটাকে আমরা বলতে পারি সাবগ্রাফ। ওই গ্রাফটাকে বলা হয় সাবগ্রাফ। ইজ ইট ক্লিয়ার? Subgraph.
Yes, sir.
Let us see an example. Say it is K5 and it is C5. So in the K5, V is, for example, it is A, it is B, C, D, E. So V is A to E, and in here C5, W is also A to E. So we can say that W is the subset of V, because all the elements of K5 is belongs to C5. And similarly, we can find these edges are the member of this set. So we can say some element of set A, E is found in set F. So we can say F is the subset of E. So as both F and W are the subset of V and E of this graph, so we can say it is a subgraph. আমি কি বোঝাইতে পারছি? সবাইকে বুঝছো এটা?
আর আরেকবার একটু বলতেন।
দুইটা রিকোয়ারমেন্টই ফুলফিল
Clear
করতে
হলো।
হবে
হ্যাঁ,
ভার্টেক্স এবং
সেটাই একটু
edge।
দেখো। প্রথম যে K5 যে গ্রাফটা আছে এর ভিতরে নোড আছে 5টা, ধরো A B C D E 5টা। C5 এর ভিতরেও সেই 5টা নোডই আছে। তাহলে সেক্ষেত্রে আমরা বলতে পারবো যে W হচ্ছে নোডের সেট। তাহলে W টা হচ্ছে V এর সাবসেট, কারণ সাবসেটের ইকুয়াল হচ্ছে সাবসেট ইকুয়াল। তার মানে ইকুয়ালও হইতে পারবে বা 3টা নিয়েও যদি করে সেটাও হইতে পারে। যেহেতু সবগুলো আছে তার মানে আমরা বলতে পারবো W টা হচ্ছে V এর সাবসেট। আর E টা হচ্ছে এজ এর সাবসেট। তাহলে এখানে এজ আছে তোমার 10টা। কিন্তু 10টার ভিতরে এখানে তৈরি করা হয়েছে 5টা নিয়ে। বাইরের 5টা, ভিতরের 5টা নাই। তাই যদি হয় তাহলে ওই 10টার ভিতরে 5টা আছে না? তাহলে আমরা সেই ক্ষেত্রে বলতে পারি যে F টা হচ্ছে E এর সাবসেট। তার মানে W টা হচ্ছে V এর সাবসেট আর F টা হচ্ছে E এর সাবসেট। দুইটাই হচ্ছে আমার এই গ্রাফের সাবসেট। তাহলে সেই ক্ষেত্রে we can say that C5 is the subgraph of K5.
স্যার আমরা কি C3 কেও কনসিডার করতে পারবো সাবগ্রাফ হিসেবে?
হ্যাঁ, পারবো। তখন নোড 3টা থাকবে। সমস্যা কি?
কিন্তু স্যার শেপটা তো মেইনটেইন হচ্ছে না।
থাকুক, শেপের দরকার নেই তো। আমার কন্ডিশন হচ্ছে W সাবসেট উইল বি V। কন্ডিশনে যে আগে তোমার স্লাইডটাতে বলা আছে। সাবগ্রাফ তখনই হবে যখন W টা V এর সাবসেট হবে এবং E টা F এর সাবসেট হবে। শেপ ডাজন্ট ফ্যাক্ট। কন্ডিশন হচ্ছে এটা।
ওকে স্যার, গট ইট।
So when a graph maintain this condition, we can say that graph will be the subgraph. Next one is the union. Union of two graphs. How? Consider there is one graph G1, another graph is G2. So the union of these two graphs will be V1 union V2 as well as E1 union E2. That means both number of set of the vertex and number of set of the edges will be union or added. See the example in here. So W5 is a one graph, S5 is another graph, and when we union these two graphs, no, S5 and C5, S5 and C5, we union S5 union C5, then we are getting W5. তাহলে এটা number of nodes আর number of edge দুইটা মিলে হচ্ছে এই গ্রাফটা চলে আসছে W5। বুঝছো এটা? দুইটা গ্রাফকে আমরা যদি ইউনিয়ন করতে চাই, if we are like to make the union of these two graphs, all the nodes and all the edges will be combined together. That will produce a set union of the graph. Clear?
Yes, sir.
Next one is adjacency list. So you need to prepare this kind of adjacency list. This called a table where one column will be the vertex. That means how many number of vertex in this total graph. So in this graph, how many vertex are there? A, B, C, D, E, F. So you need to write like this, A, B, C, D, E, F. Then in the next column, you need to write the adjacent vertex. So A is connected with B and C. So B and C will be the adjacent node of A. Do you got my point? Do you got my point?
Yes, sir.
So in the adjacent vertex list, we need to write A adjacent vertex is B and C. Similarly, B is connected with A, C, F, and D. So there will be 4 adjacency vertex. Then C, E, and F. So this is how we need to prepare the adjacency list, where it is a table of 2 columns of the vertex and adjacent vertex. Is it clear?
Yes, sir.
For example, you will be given a graph like this, and you need to tell that you need to prepare the adjacency list of the graph. So how can you do it? You need to prepare this type of table where the vertex and adjacent vertex need to be mentioned. Next one is the adjacency matrix. What is adjacency matrix? Let us see. Adjacency matrix is represented by matrix A, where Aij is 1 if Vi and Vj is an edge of G. Otherwise, it will be 0. For example, you can see V1 and V2. Okay, so how you write this? It will be written like this way: V1, V2, V3, V4, V5, and V6. Similarly, in here is also V1, V2 up to V6. Then you need to find that there is a connection from V1 and V2. So V1 with V2, so there is a 1. V1 with V3, V1 with V3, so you can find there is a 1. So V1 and V2 is the edge of this graph, so there will be 1, otherwise 0. Is there any loop V1 with V1? Is there any loop in this graph? Is there any loop?
No,
There
sir.
is no loop, so you can see it is 0. Similarly, is there any edge V5, V3? This is the V5 and V3, or V5, V6. Is there any line in here?
No, sir.
No line. So you can find that V5 with V6 is 0, and V5 with V6 is also 0. So this is the adjacency matrix where we need to mention about the edges, And incident matrix is denoted by the M, where the value of matrix will be 1 if the edge is incident. Otherwise, it will be 0. What is incident? Can you remember about the incidence? For example, this is E1. For example, this is E1. So E1 is connected with to whom and whom? E1 is connected with V1 and V2. Clear? Is it clear? Already I have discussed this incident matrix in the previously of this chapter. So you forgot.
Yes, sir.
So E1 is connected with V1 and V2. So both V1 and V2 will be 1. Next E2. E2 is connected with V1 and V3. So this one is V3. Okay, hold on. I became also confused. The previous one was connected with the directed graph, but this one is not the directed graph. That is the problem. Let me check from the textbook.
স্যার আপনার ভয়েস শোনা যাচ্ছে না স্যার।
শোনা যায় এখন?
জি স্যার, ক্লিয়ার।
Okay. So the incident matrix that I discussed in the previous lecture, that is related with the directed graph, but this graph is not the directed graph, it is the simple graph. Okay. So I need to check from the textbook and let you know. Hold on a minute.
স্যার আপনার ভয়েস শোনা যায় না।
আমি কিছু বলছি না তো। Can you see my screen?
Yes, sir.
Okay. So there is a bit difference between the adjacency matrix and the incident matrix. See, adjacency matrix is done with node. It means A, B, C, D, and here is also A, B, C, D. Clear? So from here you can see A and B1. That means A is connected with B. Then A is connected with C. A is also connected with D, right? Then BA is connected, BB not, BC, BD no connection. Then CA, CB, CD no connection, and DA there is a connection. So the adjacency matrix is developed among the node with the node. Is it clear?
Yes, sir.
Okay. But the incident matrix is a little bit different. See from here. What do you understand from this graph? Incidence matrix is developed with the edge and the node. Previous one with the node with node, but this one edge with node. Is it clear? Do you understand this?
Yes, sir.
See from this graph, V1 is connected with E1 and E3. So V1, sorry, E2. So this one E1, this one is E2. So the V1 has both E1 and E2, that is 1, 1. There is no connection with E3, so that is 0. E4 also 0. Other than is everyone is 0. So when the node is connected with edges, that will be 1. For example, V2 is connected with E3, E4 and E6. So you can find that V2, E3 1, E4 1 and E6 1. Do you understand this?
Yes, sir.
Okay. So let us find from this slide. Okay, now tell me, what will be in here? What should I write in here?
Edges.
E1, E2, E3, E4, E5 and E6. And in here, V1, V2, V3, V4, V5. Okay, now see, the V1 node is connected with E1 and E2. So that's why these two are 1, 1. Other them are 0. Then V2 is connected with E1,
E5.
E5. No, this one is E6 and E5. So there is a mistake in here. There should not be E3. Okay, my mistake. They have mentioned edges in here because we have 5 edges. 1, 2, 3, 4, 5. This one is E1, E2, E3, E4. This one will be E5. And number of nodes are 6. So V1, V2, V3, V4, V5 and V6. Now clear?
Yes, sir.
So see, E1 is connected with V1 and V2. So E1 is connected with V1 and V2. Okay. E2 is connected with
E3.
V1 and
V-
V3. So V1 and V3 1. Then E3
E3 and V6.
E3 is connected with V3 and V6. So V3 and V6. Then E4 this one will be E4. So V2 and V6. V2
Yes, sir.
and it should be V6. And this one
V2 and V.
V2 and V5. Okay. This one is E5 and this one will be E6. So E6 is V2 and V6, V2 and V6, and this one V2 and V5, V2 and V5. So the adjacency matrix is developed with the node matrix, and incident matrix is connected with the edge and node. Got my point?
Yes, sir.
So if a question is
Sir.
given like this, that you are given a graph, you need to find the both incident and adjacent matrix. Is it possible to find?
Yes.
Yes, sir.
Okay, that's all for today. So do you have any confusion regarding to this discussion? Any confusion?
No, sir.